To start off the second half of this chapter, we're going to talk about the distance formula. The distance between 2 points A and B is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now you might have seen the formula looking like this before, but I think that this is kind of long and a little bit ugly to deal with. So instead of writing it like this, in this class we're going to use the distance formula as the change in x squared plus the change in y squared, and then take the square root of that. In an example problem, you'll see what I mean. What is the distance between point U, which is at negative 7.5, and V, 4, negative 3? And we want to round our answer to the nearest tenth, so take it out 1 decimal place. So what I'm going to do is I'm going to write my coordinates. First I'll start with my x's, and I'm going to think on a number line, how many units are between negative 7 and positive 4? So think I'm going 7 units to the left, 4 units to the right. So my change in x is 11. Next, I'll look at my y coordinates. I'm going 5 units to the right, 3 units to the left, so my change in y is 8. From here, all I do is plug this into my formula, so I get the square root of 11 squared plus 8 squared, which is the square root of 121 plus 64, which finally is the square root of 185, which, rounded to the nearest tenth, would be 13.6. Let's look at one more example here when we're given these in a coordinate plane. And we'll talk about a shortcut in the very end here of when you're given a picture like this. I want to find the length of AC, which is really basically finding the distance from point A to point C. So A, I can see is at 1, 1, and C is at 5, negative 2. I can do the same process over again. The difference between 1 and 5 is 4, so that's my change in x. And the difference between 1 and negative 2 is 3, so that's my change in y. Plugging this into my formula, I get the square root of 4 squared plus 3 squared, which ends up being the square root of 25, which is 5. Now, a shortcut that we could do here, when I'm given my coordinates or I have like graphing paper handy with me, is I can start to make a right triangle to find the length of AC. So, I'm going to draw from A to C horizontally first. I can see that's 4 units long, and I can count these because anything horizontal or vertical, just a straight line, I can count. Then going down to C, I have 3. Now finally, I want to find the length of AC. Notice here that when I went horizontal and then went vertical, I made a right angle. So I have a right triangle with the missing hypotenuse. I have legs 3, 4, and you might know this as your favorite triple, that the hypotenuse here would be 5, which matches up with what we got. Now in this example, you could really use either way. Just know that if you're given a graph or you have access to graphing paper for any of these problems, you could use the Pythagorean theorem if you want to do that.